Cambits is the idea of a reconfigurable camera system. What's happened in recent years is this emergence of computational imaging, which is the convergence of new types of imaging hardware and optics with computations to produce new types of images.
Today, the brightly color-coded Cambits system is capable of creating 12 different types of computational cameras.
Designs that would capture panoramic images, refocusable images, stereo or depth images, microscopy, and kaleidoscope or light field images. You could take a bunch of images using your phone and stitch them together to create a panorama. But it would be even more powerful if you can snap a shot that captures the entire world around you. And those kinds of devices require you to move away from the conventional model. Instead of thinking about one thing that produces one type of image, if we could look at it as a set of blocks with different functionalities. They may be the sensors, the optics, the actuators that can move things around, optical attachments and light sources. So now we have sort of a kit that you can put together to create a new camera that produces a specific type of image. And that was really the genesis of Cambits.
Professor Nayar started the Vision Lab at Columbia University over 20 years ago. His work in the field of computer vision, creating machines that can see, sparked a new idea.
The thing that struck me is that there's no compelling reason why machines should use cameras that were developed for television and photography. Perhaps we can capture light in new ways to enhance the intelligence of machines. I was interested in how machines, as in robots or cars, would benefit from new types of images and cameras.
Perfect timing. Makoto Otomaki, an engineer at Ricoh in Japan, was visiting Nayar, and they began to explore the idea of a reconfigurable camera.
Makoto and I worked together on the project, but when it comes to the implementation and the engineering aspect, most of the burden fell on him.
The team spent the first 6 months of the 2-year project making diagrams and trying to solve some practical problems while keeping Cambits user-friendly.
The idea that you can put two blocks together, one a sensor, the other one an optical system, and have them talk to each other without having to connect cables, that requires you to rethink the design of a camera system as a whole.
The two men focused on the most important features needed for a successful reconfigurable camera. First, it needs to be easy to use. Second, it must be self-identifying, which means the host computer should know what the configuration is. Third, it must have diverse functionality. And finally, scalability. There must be no constraints to adding new functions.
The spirit of Cambits was always to turn it into something that the community would be excited by, not to make it proprietary, but to actually put it out there as a concept, share the design so that others could add their own modules to it and further enhance the functionalities.
In its current form, Cambits allows the user to decide what configuration is needed. But Nayar says artificial intelligence and imaging could be the next step.
Imagine that you had an intelligent camera that was faced with a particular situation, and very much like a Swiss Army knife, is able to put itself together to capture the image that's most pertinent to the robot or to the human being. A reconfigurable camera with some level of artificial intelligence would make it a really interesting device that would probably have far-reaching implications.
Learn more from the contributed article Cambits, a reconfigurable camera system, in the November 2017 Communications of the ACM, which illustrates the modular nature of Cambits with 4 different covers. Each one depicts a distinct configuration.